Okay, this will be part 3, starting with question number 20. Given that L and M are parallel and that T and S are parallel, it gives you the measure for angle 2 as 112, and it says find the measure of all other angles. So essentially all the angles that I'm circling are congruent to each other somehow. So if you look at corresponding angles, you can look at these are vertical angles, so they're congruent and then corresponds with this. You can look at these are alternate interior angles. There's so many different ways to look at it if you needed to prove it, which you don't. So all the ones that I circled are 112. All the ones not circled would be a linear pair to all the ones that are circled, and those are all 68. So if number 15 is 112, 16 is a linear pair, which is how I know that it's 68, so I have to equal 180 degrees. Number 21, given that I have parallel lines solving for x, if this is 70, then this is 70 because those are vertical angles. And if this is 70, then this is 70 because those are, those are corresponding angles, which means that this has to be 70 because those are vertical angles and are congruent. So 3x minus 5 has to equal 70. And then when you solve for x, you add 5 to both sides. 3x equals 75 and x equals 25. And then to solve for y, if this is 70, if I add these two together, they have to equal 180. So 2y minus 8 plus 70 is 180. And then I would have to subtract 70 and add 8. And then divide both sides by 2. And y equals 59. Alright, moving to 23 through 25, we're talking about triangle congruency. It's going to be very important during your test if it's asking you about congruent triangles, which is the same size, same shape, or if it's asking about just similar triangles, which would just be same shape. So remember, for congruent triangles, we have SSS, SAS, AAS, what else? HL, and I'm missing one, ASA. This is only for right triangles. Right triangles can be classified using the other ones, but this one can only be used for a right triangle. So we have number 23. Don't forget about the reflexive property, which would tell you that these two sides are also congruent to each other. So my reason here would be angle, side, angle. And then when I'm writing my congruency statement, I always just write one of the triangles first. So A, B, D. And then I match things up. So A and C go together because neither one of them have any markings. B and B actually go together because they both have the single mark. And then D. Number 24. AC is the perpendicular bisector. So perpendicular would mean that they're right angles. Bisector would mean that these two parts are congruent. And then we know again, because reflexive, that those are congruent. So in this case, we have SAS. And again, I'm going to just pick one triangle to write, A, B, C. Then when I'm writing my congruency statement, my A is at the top up here. It's this little one. So A. And then I move down the reflexive to the right angle, which is C. And then I went out this way, so I got to go out that way to D. Number 25. AB is congruent to DC, so I always mark my picture. AD is congruent to BC. And then again, I have a reflexive side. That reflexive side is used a lot. So this would be SSS. Now this is where the congruency part's going to be important. So I'm going to do A, B, D. So I started with A, which is between the 1 and the 2. So I go between the 1 mark and the 2 mark. So I start with C. Then I'm going to go this way across to B, and I moved across the single mark. So I'm starting here, I got to move across the single mark to D, and then up to B. This picture might look a little confusing to start with, but just kind of, you just got to go with it. A median, I need a place to write these down. So for number 26, a median connects a vertex to the opposite midpoint. So I need a vertex to an opposite midpoint. So here to here, I know this is a midpoint because those are marked as congruent, so it's the middle of this segment. So CD would be a median. Perpendicular bisector has to be perpendicular, so I'm making a right angle, and it cuts opposite side in half. So it has to be perpendicular, and then it has to cut it in half. So these are my only 2 choices. This one's perpendicular, but this part and this part are not marked as congruent. This is perpendicular, and those 2 parts are marked as congruent. So it's connecting a midpoint. So 27 has to be DG. That's listed as ray DG. 28 altitudes are perpendicular, and it goes from a vertex to the opposite side in a perpendicular manner. So that would be my AF. And then finally 29, it cuts an angle in half. And so my angle bisector, I would have markings here to cut the angle in half. So that's BE. And then if this was an isosceles triangle, that would mean that if it's from the vertex of the isosceles triangle, so I'm talking about this line from here to here, it would be a median, it would be a perpendicular bisector, it would be an altitude, and it would be an angle bisector. So all 4 of them are the same segment from the vertex angle. Not from these angles, they would look different, but from the vertex angle, this single segment would be all 4 of these things. Okay? Moving on to number 30. So number 30, remember the point of concurrency is when all 3 of these are drawn in the triangle and it's the point that they meet in. This is not on your exam, so I'm just going to write these and move on with life. Number 31. So using the same picture for all of this. So KM is a median. Remember, a median connects a vertex to the midpoint. So this is the midpoint, so those have to be the same. So marking the diagram is what I just did. Now based on this, rather than true false, I'm going to talk about whether I can or can't assume. So JKM and MKL are congruent. Based only on this picture, I cannot assume that. I cannot assume that this angle and this angle are congruent based on just knowing this. If it was an isosceles triangle, I could. JM and ML are congruent. I marked that. That's true. KM and ML are perpendicular. I cannot assume that either, unless it was an isosceles triangle. So this is kind of saying that this is an angle bisector. This is saying that it's a median. This is saying that it's a perpendicular. Well, I guess this is kind of saying that it's an altitude. Or a perpendicular bisector if it was bisecting also. But yeah. But if it was isosceles, they would all be true. Because it's not isosceles, we cannot assume any of those things. Find the measure of angle 1. So there's a couple different ways that you can do this. Either you need to know that this is 35 because that's a vertical angles, and then you can find out that this is 70 because that's a linear pair, and then you can do 180 minus 70 minus 35 to get angle 1. Or remember remote interior angles, which says that angle 1 plus 35 has to equal 110. So these two angles added together has to equal this exterior one. And that's just the remote interior angles. It's a postulate we learned a long time ago. But you can also just solve it by looking at this and subtracting from 180 because that has to be 180. Either way you solve it, then angle 1 equals 75 degrees. Number 36, a musical triangle made out of steel wires in the shape of an equilateral triangle. So all the sides are the same. Each side must measure 10 inches. How many total inches of steel wire is needed to make 5 triangles? Well, this equals, oh goodness, my lights just went out of school. Hold please. Apologies. So all 3 together have to equal 30. And if I want to make 550. Musical triangles come in many different shapes and sizes, not just equilateral triangles. Sometimes they were isosceles or scalene to create different sounds. Study the picture of the isosceles musical triangle below and answer the questions. So these two are the same because it's isosceles. The vertex angle, you'd have to know where that is. That's the top. Remember, these are called base angles. Ask for the measure of each one. So I have to subtract 116 from 80, which would give me 64. And then these have to be the same because it's an isosceles triangle, so I divide that by 2, so each one is 32. From the given information, which angle measures the most? Angle P is the biggest. The least would be angle R and angle Q. They're equal, but they're still the biggest. To find out the shortest sides, they have to be across from smallest angle. So if these are my smallest angles, my shortest sides would be RP and PQ. And then the longest side is across from biggest angle. So that would be RQ. This information is true for every triangle. So if you're trying to put them in order or trying to find missing angles or missing sides, the biggest side has to be across from the biggest angle and the smallest side across from the smallest angle. I'm going to stop right there because I think this next question will take longer than I have left on my video.